3-4. We're learning about asymptotes. Rational functions, asymptotes. What's that? Oh, can't touch this. I get it. An asymptote is if I had this line here, this line is going to get really close to the x-axis, but it's never going to touch the x-axis. What would be an example of an equation that would be like that? 1 over x. In other words, we can never have, 1 over y would be it too, but I guess y would never equal 0. Oh, my back. My back is getting worse as the day goes on. If I had 1 over y, all right, we'd never get to where y could be 0 because it'd be undefined, right? The same thing as if we said 1 over x, and then we would go up this way, and here's my y. It would get real close, but could never touch up here. All right? So I would have a horizontal asymptote. We'd have a horizontal asymptote of x, and I would have a vertical asymptote of y in this case. Asymptotes, it'll never touch them. It'll get real close, but it'll never touch them. That is, to me, the best definition of an asymptote. All right? The classic one is always 1 over x. What if we had x squared? If we were to graph x squared, if we were to graph y equals x squared, is there an asymptote in there? We could have 0 in here. What does that graph look like? What's it never going to be? Is it ever going to be a negative y? No. So just below the 0 down in here, not touching, we would have a asymptote. Because it could never be down here. I bumped it. All right. So, in essence, that's really what an asymptote is. I got a mess. Now, what if we were to add something to this? What if we said y equals 1 over x plus 3? And we were to graph this. Where would our asymptote be? Let's take a look. We can't have x equal to 0, right? But if x equals 1, then we're up 3 up here. If x equals 2, then we're at 3/2. What's happening? If x equals 4, or 3 I mean, then we're at 3 1/3. It's coming out farther. Where's our asymptote going to be at? I want to draw a good graph instead of my little ones. Equals 1 divided by x. Slide that over. Plus 3. Why don't you watch what happens? What we were actually graphing is this line right here. All right? X can't equal 0, but also notice that y can't equal 3, right? If we're graphing this, how do we get x equals 0 in there? We can't. Right? So it's going to get really close to 3 in this case, but it's never going to touch it. So my asymptote on this one is going to be, my horizontal is going to be y equals 3. There's going to be one of my asymptotes. And my vertical asymptote is going to be where x equals 0. Those are my two asymptotes for this equation. So if we were to change this up a little bit, let's say, and instead of plus 3, we used minus 3. Put it down there, hey. I didn't want to go to that yet. Minus 3. Then it takes our graph and moves it down. So y, obviously if x is 0, right, becomes undefined, but the value we won't be able to get is going to be negative 3. Do you see that? See how that works? The next one I wanted to go to. What's that? What? I can't hear you. Next one I wanted to do is I wanted to put this down below. Come on down. Because it changes where these lines go. Now, if you take a look, x can't equal 3 in this case. X cannot equal 3 in this case. Because if x equaled 3, we'd have an undefined function. What's that? Oh. Miss Cross. She's a good lady. All right. So now we notice what happens. As we put a value, Danielle, in the bottom down here, it's going to change where our asymptotes are going to be. We are now, in this case here, x can't equal 3 because it would be undefined. That means y will never equal 0. Because we can't have a 0 down here. We can't get this to 0. What happens when we do something like this, though? Something in that nature. Actually, we could change this here to 3. Yeah. All right. Change that to 3. Let me take a look. Let's take a look at this for a second. What? Yeah, like this here. Starting to look kind of funky, isn't it? Now, where would my asymptotes be on this one? Where would my asymptotes be? And how can we figure out our asymptotes for this one? Let's take a look at what we can do here. Can x equal 0? Why not? Sure it can. 0 over 2 is 0. Right here. All right? What can't x equal? We would have to solve this. X squared plus 3x plus 2 plus 2 equals 0. And if we FOILed it out, we'd come up with x plus 2 and x plus 1 equals 0. Negative 2 and negative 1. Here's our negative 2 coming down here, and I'll bet you at negative 1 there's another one right here. Right? It can't equal that. But in between those, if you watch, this line goes up here, right? It doesn't touch up in here either. But in between those, it can equal, right? It just cannot equal, x cannot equal -2, and x cannot equal -1. All right? Those are where your asymptotes are at. Is there a horizontal asymptote? Look at where this is. And this comes up and it stays, it kind of almost comes back down to 0 a little bit, doesn't it? This comes up almost to 0 here. You do end up with vertical asymptotes. They're going to run right along this line, and they're going to run up here along this line up here. All right? Horizontal asymptotes. Your vertical asymptotes are the ones that you really want to recognize on this. All right? Those are the ones you should recognize through this. All right. I'm going to tell you that for this assignment, you are going to need to do some factoring. All right. For instance, you will have something that looks, if I had x squared minus 1, how does that factor out? Can you tell me? These you got to start getting real quick. How does this factor out? +1 -1. So x can't equal -1, and x can't equal +1. Right? Okay? And that's when you have it over something. Let's say like that. Okay? Let's do we're not going to get into those kinds of sketching. I want you, let's see, they have graphing each rational function. I don't know if I want you graphing those. I want you, here. I want you to do page 140. Page 140. I want you to do 15 through 18. I want you to do to graph some equations. I want you to graph them yourself so that you can check them on Desmos. All right. There were some good ones here. Let's do 24. Um, 28. 31. And 38. Do those right there. Again, you can graph them yourself using the T-charts, and then I want you can turn around and you can use Desmos on these to be able to come up with, to see if you got it right. Yes.